So the problem is synthetic polymers are not biodegradable. Only 10% of the polymer is actually recycled, less than 10%. So now we have huge mountains of polymer that is deposited over the sea. Our idea is, why don't we make use of these plant fibers as a replacement for these synthetic fibers? Yes, of course, these plant fibers have many drawbacks. So if you look at the strength of this material, I mean plant fibers, it is nowhere near synthetic material. But at least we can replace in certain applications, especially for semi-structural applications. So basically Stanford and elsewhere, they bring this 2%, a world 2% scientist. And I was there in that particular list. So our research area is more focused on biodegradable polymers. We are working in active food packaging, smart food packaging. Suppose if you pack or if you cover your food materials, then suppose if your food spoil means we can indicate there will be some color change in our film. But at the same time, our film is also made up of this bio-based material. So to get this results, we need an optical microscope, and we need to follow the phase separation with that optical microscope at different temperatures. And getting this correct result is getting these photographs is really challenging for me. Our instrumentation center, we have almost all facilities here, and we have our XRD machine, and we have our scanning electron microscopy. So different machines are available at our laboratory. Research is, it's a passion. It should be, the first thing is our society. So we have to contribute to the society. It is actually a dedication.